Right, good afternoon, everyone, and thank you for joining us. This is Sarah Davison with Viavi Solutions Marketing. I want to thank you for joining our call today on the tracking generator function. I have just a few housekeeping notes to share with you. I'd like you to know that this webinar is being recorded and will be available for you to review or share with your teams in approximately 24 to 48 hours. An email to all attendees with a link with the recorded version will be sent out to you. All lines are on mute, but we are monitoring the chat and will answer questions at the end of the webinar or reach out to you individually to ensure you get the answers you seek. And now I'd like to turn it over to our speaker today, Bill Nichols.
Thank you, Sarah. And I'd like to thank you all for joining us today. I'm Bill Nichols, Field Application Engineer for Viavi, based out of Wichita, Kansas. And also joining us today is Mike Fortna and Dave Hansen, also out of Wichita. And they're here to help answer your questions as we take the deep dive into retuning a duplexer and doing an antenna and distance default sweep. So what is a tracking generator? A tracking generator works by tracking the sweeping first local oscillator of our spectrum analyzer to generate an RF carrier at the same frequency, which the spectrum analyzer is tuned to at that moment. You're essentially transmitting and receiving at the same time in order to plot the gain loss magnitude of the device you're testing. You can use it to align and test filters and do RF frequency response. You can do distance default plots, measuring cable lengths and finding transmission line faults. This requires a 50 ohm power divider and a 50 ohm termination. You can also do return loss and VSWR sweeps, measuring antenna performance and tuning, and that requires an external return loss bridge. And this is a picture of our kit over in the lower corner down here. And you can see our RF power divider, our return loss bridge, and we have a couple of cables to connect those devices to our 8800 service monitor, and then we also have the 50 ohm load in that kit. So here is a reasonable facsimile of a duplexer. I tuned a duplexer here at the factory and made a video of it. It took about 45 minutes to tune that duplexer, retuned it to separate frequencies, to different frequencies. And so we only got about 45 minutes here, so I had to cut down that video quite a bit. So the things that I did cut out were basically the changing the cables and that sort of thing. I tried to keep the like the sweeps on the tracking generator in real time, so you can see how quick our response is on our tracking generator as we go through the alignment on the duplexer. Now, this particular one is a band reject or pass notch duplexer. It's got 6 individual cavities. You've got 3 cavity resonator groups in each of the duplex branches. So basically, I've got my high pass over here on our left side over here, and the low pass on the right side. And a little bit about what you see here with the lines that I've got drawn on here. These represent the cables. I couldn't freehand the cables very well and make it look very attractive. So what I did was I just drew straight lines in here. And of course, we're never going to see 45-degree angles or 90-degree angles in our cabling, but this is showing our signal path. Now, just for an example, what you would, for folks that are just learning about duplexers, let's just say that we've got a 100-watt transmitter out here, and it's going to be coming in this first resonator cavity, and it will resonate and get picked up by the pickup loops, and then it'd be transmitted to the second resonator, resonate in that cavity, and then it will be picked up by the loop and transmitted out to the third cavity, and then it will be transmitted out the antenna port through our transmission line and then out the antenna. So you only want basically less than a dB of loss through your cavities here, and so you've got pretty close to 100 watts coming out. And you also, at the same time, simultaneously, you're going to have a receiver frequency coming in at about meg 80 or maybe all the way down to -100 or maybe a little bit lower. So you need good isolation between the two, and that's what these duplexers do. The duplexers allow you to transmit and receive on a single antenna, and that saves you cabling and extra antennas, so you can be more efficient on your site setup. So basically that receive frequency is going to be coming down that same antenna that our transmitter is going out, and it will be going through the 3 resonators on the low pass side and then out to the receiver. Now, before we get started, you would want to take the cables that you are going to do your realignment with and connect them to the antenna port of the service monitor and the generator port of the service monitor, using an adapter and a coupler to couple those together, to adapt those, to couple those together. And then at that point, you'll do a set reference, and then that references out all the loss in those cables, and you can connect it to the duplexer. You're going to see the set reference operation through a few times during our presentation here. So I'm going to kind of skip it on the front end here, and we'll just go ahead and get busy here. So the first thing you've got to do if you want to realign your duplexer is you've got to take the cables off. And so I'm just going to easily take them out of the picture here. And so we can kind of see what's going on here. So you're going to put a T on your 2 cables that you just did the set reference and referenced out all of the loss in those cables. You're going to put a T connector on those. One side of the T is going to go to the generator port. The other side of the T is going to go to the antenna, and the third port on that T, or the middle port, is going to be connected to the resonator cavity. So we're just going to start on the low pass side. This is probably the easy part. You're just going to be using the 3 plungers. You can't see the other 2 plungers that are on the low pass side because my 8800 is in the way, but you're going to be adjusting these plungers to peak out the signal on that particular frequency. And the other thing I did in here was I do have markers set at our high and low pass frequencies. We'll talk more about markers here in a little bit too. So we're just going to go across these 6 cavities and peak each cavity for their particular frequency, whether it's the low pass or the high pass. And then once we reach the end and we've peaked the last cavity, this high pass cavity over here, we're going to switch our frequency. We're on the high pass right now, but we're going to switch our frequency to the low pass notch frequency. And instead of using the plungers to peak those signals out, we are now going to use the tuning caps down here to get our notch depth. And so we're just going to tweak those caps and get the maximum depth that we can on frequency for our low pass notch on this, in this particular instance here. And this is real-time movement here that you see on the display right here. This is not, I didn't cut this to make this look faster. This is how fast you can move these. So you do get good response from the tracking generator. You're gonna have to tweak and wait for the next, for the next sweep to update. So now I'm changing my frequency to the high pass notch. And on the low pass resonators down here, you notice we have 2 caps. So you do have, they are interactive, and you'll have to go back and forth to give you the maximum depth on that high pass notch. And then we'll peak our last, or get our depth on our last notch. And now we have connected all of our cables back. Now, like I said, it took 45 minutes to do this, and this is part of what takes the time is connecting and disconnecting the cables on here. So this would have taken a little bit of time to put those back on. But we've got all of our cables back on, and now we are going to finish our what we'll call what we just did, the rough tune, and now we're going to go back through and do a coarse tune. The cables that these represent, these lines represent, the cables are actually part of the frequency response of the duplexer. And so when you put these cables back on, it's going to shift your frequencies a little bit, and you're going to have to tweak all of those back in. So we'll be operating our plungers, and we'll be using our tuning caps to do that. So you can see that we've got a few anomalies hanging out here, got a few lobes hanging out, and so we're just going to go back through and use all three of these cavities are interactive, by the way. So you're just going to go through and you're going to just make movements in these plungers to try and straighten these out and get these lobes out of the way. And what that does is it will peak out the pass band by doing this, and it takes a little bit of time, and you might even have to make a couple of passes at it to do that. But this is all part of tuning a duplexer, and it's a little bit, it's kind of getting to be a little bit of a lost art, because we've got a whole lot of folks that have done this over the years, and a lot of them are retiring, and so they got to show the new guys how to do this before they retire. So if you haven't tuned a duplexer before, definitely get some experience tuning these, because you're going to see a little bit later when I put the return loss bridge on there. There's some really fine movements that you have to make, and you've got to get used to doing that, or it'll make your day very long. So we're just going to continue on and just kind of using our plungers to clean up that frequency response in our on our low pass that we're on right now. And now we're switching over, and what we're doing here, and now I'm down on the tuning caps, and I'm adjusting those to get the notch down, to get it on frequency and as low as possible. Like I said, we put those cables back on, and it moved our notch a little bit. And so we're just going through and adjusting our capacitors to do that. And we'll move along here a little bit. Oh, and by the way, if I could hit it quick enough, what you're seeing right here, the cables actually at this point are not on here. This is the noise floor of the analyzer. And when we get a little bit further into this, and after we put the return loss bridge on there, I want to take a closer look at those, and they kind of explain a little bit about the noise floor versus the bottom of the notch. Sometimes can be a little bit deceiving. So we're just moving along and getting that, optimizing that as best we can. Like I said, we haven't done any set references at this point. I'm just trying to get everything on frequency, and then we'll go back. And by the way, let me back up just a bit there. What I'm doing right here is I've got this adjusted about where I want it, where I think that it's probably my optimum adjustment. And so what I'm going to do here is I'm going to set the center frequency in between the high pass and low pass. So basically you take your high pass and your low pass and add them together, divide by 2, and that's going to be your center frequency. And in this particular case, it happens to be 150.425. And the reason that I do that is because I can set the span in such a way so I can see both the high pass and the low pass. And when I do a set reference, then I don't have to re-reference anything. I don't have to go through that extra process. All I have to do is just switch the cables, and I'm still in reference mode. Okay, so what we just did there, that was a little bit of the sleight of hand there, but we did set the reference. Again, I'm going to go through that reference process here a couple of times, but we have set the reference. We put our cables together, and we've referenced out all the loss in those cables, and now we are actually going to see what the insertion loss is on both our high pass and our low pass. Now, what you're looking at there, let me, excuse me, let me back up just a hair here. I'll let it run. And we'll stop it right there. So this is the high pass over here, and I've got my marker set on at the exact frequency that I want, and it's showing me that I have less than a dB of loss or insertion loss on that, actually negative 0.76 at this point right here. And if you will, I'm going to back up to the last one. I'm going to go ahead and hit it right here. So the insertion loss is less than a half, and now I've switched over to the other side, and our insertion loss is 0.76, and now I'm getting ready to look at the notch. And what we're doing here to look at this notch is we were in the dB mode, in reference mode, and we've set it into the dBm mode, and now I'm going to set the reference level to neg 40, and what that's going to do, it's going to pull that signal up out of the noise. And so you're actually going to see, we're going to get a close look at the bottom of this notch here in a second, and we can tell whether it's actually in the noise, whether our markers just kind of bounce around reading noise, or whether it's actually the bottom of that notch. And there it is. So we're at neg 94.45. And now you can kind of see that this, the marker is just a little bit, you would think off center, but there's actually a little bit of an angle on this notch, and it's actually setting at the lowest point of the notch. But we have a depth of neg 94, so we've got good isolation here between our passband and our notch at this point. I don't know if I can get that. Let's see if I can move that back a little bit. I'm switching the cables right here, so this is kind of caught in time, but that number 2 marker right there, that is the noise floor that we're looking at in reference mode. And you can see that it's at neg 95, a little bit lower than neg 95. And let's go ahead and let it play here. And there's our notch. Sorry about that. Okay, so there is our notch, and it is setting at neg 94.86. So if you remember that the noise floor was just a little bit below that, and so that notch is out of the noise floor. So if you happen to have a service monitor and you've got it in its reference mode, and maybe looks like you can see the bottom of the signal, but maybe it's quite a bit of ways from the noise floor, and the marker is sitting there telling you what the bottom of that notch really is. If that marker is moving more than a dB or a half a dB, it's actually sitting in the noise floor and it's bouncing around. So if you see that marker moving 5 dB or 10 dB, that's not the bottom of the notch. That is just the noise floor moving around. So kind of keep that in mind. Okay, and now we are ready to fine tune. We are ready to fine tune our duplexer here. So we're going to do this with the return loss bridge. So I'm actually going to set the frequencies to the high pass and the low pass. And the reason I'm going to set it instead of splitting the frequencies is that I'm going to set the span down to 1 meg so that we can get a real good look at our at the return loss on our high pass and low pass. And we'll go ahead and set the reference there at 1 meg, and I'm also going to set the, we'll probably end up with the reference level being at about neg 20. So let's go ahead and watch that. And we're going to use a 5 dB scale. And I'm just checking the notches here to make sure I've got my notches where I want them. Now we'll set the reference, and now we're going to connect that return loss bridge to the low pass. And I'm going to make a few adjustments here. We're going to adjust that reference level. Now, I'm going to let this run in real time. It's going to take about a minute, but I just want you to get a clear idea of the response of our tracking generator. I am making very minute movements on these plungers on the low pass side. I mean, 1/4 of an inch movements, and they're interactive, very interactive. So you have to go back and forth to pull this in. So you can probably see that if you make too much of a movement, it's going to move that signal clear off the screen, and you're going to have to readjust the scale and go find the thing. So this is the art of tuning these duplexers, is this portion right here, because you've got these enormous plungers, and you just are moving them just very, very minute. So the thing is that this thing's tuned up pretty good. That's the reason that I'm only having to move it a little bit, but I am optimizing it. And you probably see a little bit of difference in the assertion loss, but I was so close that you know, it might end up being tenths of a dB. But this is something that they would require you to do as a fine tune on these. So we're getting pretty close here. Like I said, you kind of go back and forth, and you kind of get the feel for this thing, so you can move these and together in a sequence to get this thing to land on the sweet spot. And there it is. We're down at about -45, and this would be an optimally tuned for insertion loss on the low pass side. And I'm not going to go through the whole thing on the high pass. I think we'll probably just go kind of show you what it looks like here. So go to the end over here, and that is our notch on the high side after I went through the tuning process, just like I did on the other one. And so I have both the high pass and the low pass retuned to my new frequencies. And if I wanted to, I could go back and go through our process again of putting our load back on our opposite side of the duplexer, and then check that insertion loss again. But I think I probably did that, but it made very little difference because I was making such small movements in those plungers. Oh, you know, the other thing I probably forgot to mention, and of course you can see it in the video, is that when you do this, you've actually got the 50 ohm load connected to the antenna port, and you have the opposite side of the duplexer, the low pass or the high pass. You have that open at that point. So kind of, I didn't mention that, but it's you can see that where that load is setting at. So that's a 45-minute process to go through to realign a duplexer. Now, if you're just doing a PM on a site, the thing to do is just to check the insertion loss and make sure that you've got good isolation. So you would just use the process of setting the reference for the high pass or the low pass, and then checking the insertion loss, and then changing your reference level and checking the notch, make sure that you've got good depth on the notch. And that process would only take you a couple of minutes really with the service monitor. And we're going to see later on that you can also capture these traces. So if you want to go out next year and to see if anything's moved on the duplexer, you just bring the captured trace up. And of course, you know, you want to have the service monitor set up in the same condition with the set reference mode. And you superimpose that captured trace on your live trace, and you can see if the thing's moved. And if they did, you can, some of the old ham guys, you know, they use that capability. They'll put that template up there, and they'll just retune that duplexer right back to the template. It does save some time. Okay. Now we're going to move on to doing distance default and antenna sweeps on the using our 8800, and going to be testing our antenna out here. So a little bit about VSWR and distance default. as far as the distance default goes, it's really a frequency domain reflection. That's a technique that we use to do the distance default, which is abbreviated as DTF. We feed a swept frequency signal into the transmission line, and our receiver measures the interference pattern generated when our swept RF output signal adds and subtracts with the reflected signals from the faults and the other reflective characteristics within the transmission line. So it's kind of a mouthful, but basically we just sweep that line, and anything out there that is an impedance mismatch is going to reflect that signal back, and we'll see that on our trace on our tracking generator. And the other thing that we should probably talk about is what VSWR is. That's stands for vertical standing wave ratio, and standing waves represent power that is not accepted by the load, or in this case our antenna, and is reflected back down the transmission line. In our public safety two-way systems, everything should be matched to 50 ohm impedance. The cables should be 50 ohms, the transmitter should be 50 ohms, and the antenna should be a 50 ohm impedance. So in a perfect world, the transmitted signal would travel down the transmission line and out the antenna. But of course, ours is not a perfect world. So what can happen is you can end up with impedance mismatches along the way, whether it's a bad connector, corrosion, damaged antenna. And at that point, the transmitted signal can't get out the antenna, or not all of that signal can get out the antenna. Power cannot just disappear. The power that is not transferred out the antenna has to go somewhere, and it travels back down the transmission line into the transmitter, which can cause damage to the transmitter. Now, today, most of our modern transmitters have Vswr protection. They have circuitry that monitors the Vswr, and they will reduce their power or shut the transmitter down completely. And those are two things that you really don't want to happen at your base station. So we're going to kind of show you how to test for that. So again, what we have here is we're back with our return loss bridge. We used it in the last measurement or alignment that we did on our duplexer, and now we are using that same device to check our antennas. And basically what I'm doing here is I've got the return loss bridge set up here. And when you do this, you have an open on the device under test port, if you will, when you do this. So it's very simple calibration. On some devices, you have to do a short open and load, and it takes a little bit of time to do that. So this is very simple. You just hook it up. Now I am going to reset my frequencies to the approximate frequency of my antenna out here, and we're going to change the span. I'm going to set it out to 100 megahertz here. Is actually this antenna's got a pretty wide band to it. And now we've set the reference, and we've connected the duplexer to the antenna under test. And here's what the plot would look like. This is a return loss plot. And a little bit about the markers. If we can get to it, it's like a little bit about the markers here. We haven't talked about these yet, but we've got 6 markers. And once you have the markers up, you can control them with the icons down here. You'll add markers with the add icon, and you can move the markers left or right, coarse tune or fine tune. You can do a marker to peak or marker to valley. And what we've done here is we've done a marker to valley. And what that's done is it just moved the marker into the lowest point on the screen, which happens to be on our return loss plot, our best point. And it's telling us that we have a return loss of about negative 20.95. Now, with other service monitors, if you wanted to know what the VSWR was, you would have to, get online and look up a conversion chart, or maybe have one with you. But our service monitor has the capability of doing the VSWR for you. It actually changed the scale out here, and we're going to see that operation next. So what I'm doing is I'm reducing the scale, and then I'm going to go ahead and put it into the VSWR mode. And there is our antenna. So didn't move the marker any, because it basically just taking that return loss and calculating what it is and putting it on the display here. And it's telling us that we have a return loss of 1.2 to 1, if you will, or a VSWR of 1.2. And that's pretty good antenna there. You know, there's always varying degrees of what's acceptable out there. Sometimes it's 1.5 or 2. That kind of depends on your situation, I guess. But one of the interesting features that you can do with these markers is that you can do delta functions with them. So if you wanted to actually find out what the bandwidth of this antenna is at some particular point, and I think I set these markers somewhere below 2 here, you can easily find out what the bandwidth of that antenna is at a particular amount of VSWR. So we're going to go down here and we're going to put up another marker up on the screen. So what we're going to do. So I'm moving, you can move these markers with your fingers, you can move them with a mouse, you can connect the service monitor to a PC and move them with a mouse from the PC. And what I've done here is I've just added another marker, and I'm just freehand putting that marker on the trace out here. And at that point, I'm going to do a delta function on this. Okay, so I'll let it run just a little bit longer there. There we go. So what we did was we selected the delta function, and at that point we had marker 2 highlighted. We hit the delta function, and then we could pick what marker that we wanted to do that delta on. So let's say that I had you know, maybe a situation where you're doing a combiner and you've got all 6 markers up there. You can do a delta between any 2 markers that you want. So that's a kind of a nice feature in there that most service monitors don't have today. So it's basically telling me that I've got 11 megahertz bandwidth on this antenna. So that's a pretty darn wide, but you know, you can have a lot of frequency pairs within that 11 megs for sure. So that is one way to test your antennas. And by the way, this in my demonstration here, I am using a portable antenna on a ground plane, which I don't recommend you doing to try and test a portable antenna, but I just use it for just for an example. So the actual frequency response of this in particular portable antenna that I've got on this ground plane is probably skewed a bit from what you see here, because there is another process to actually test portable antennas. But I like using the ground plane and putting that portable on there just as an example of how you can do these types of measurements. Okay. Now, one of the other things that we can do, you know, we talked about that compare mode earlier when we were talking about our duplexer and how you can save traces. So we're going to kind of go through the process here. So let's say that you are doing your annual PM and you're going through all of your tests and you get to the point where you're sweeping your antenna or even tuning the duplexer. You can go in here and save these traces, and then next year when you have to come out, then you can just bring that plot up and see if anything's changed out there. The response of that antenna has changed for any reason, any environmental reason or anything like that. Okay, so we'll let it run here just to show you how that works. So basically, I captured the trace and I've given it a name, and we've called it Site 4 Antenna 3 just for in no particular reason. I made the name, and then I decided, since I called it antenna 3 when I made the diagram, I thought I'd put 3 antennas up here to give you an idea that I was testing one of these antennas. But you could do that. I mean, most of your towers have got more than one antenna on them, of course. So this is something that you could certainly do. So I've saved it as Site 4 Antenna 3. And now, if I wanted to recall that trace, I'm going to pull the antenna off at this point, so you won't see it there. Now I'm going to recall the trace. Now, of course, like I said, you want to have the service monitor optimized on frequency with the set reference to be able to do this. But this is what the plot would look like. So I've superimposed that right back over it, and it's just almost identical. I mean, it's infinitesimal differences between that, and it's basically because the signal is going to move a little bit. But that is a great feature that you could use to on your annual PMs, just to make sure that everything is as it was the year before, and you can put it in your documentation. You can also, again, remember you've got the camera icon, and it is down on that lower gray tab down there. So if you tapped on that lower gray tab, you would see a little camera icon, and you just tap that, and it will immediately take a screenshot of whatever it is that you want to document, and it'll save it internally to the file manager, and then you can use the file manager and pull that out at some point and put it into your documentation. Okay. So now what we're going to do is we are going to move into the distance default here. And I'm going to try and capture this at the right time without moving my finger too much here. There it is. So what we're doing here is I've taken the return loss bridge off of the service monitor. I've put the power divider on. These two items are in that kit that we talked about early in our presentation. And on this one, we don't have an open out here on our device under test port. We do have a 50 ohm load out here, but it's hooked up the same. I guess I probably ought to mention this. We have one port on both of these that says antenna. And of course, that can be confusing because you're getting ready to test an antenna. So you would think possibly that that's the port that goes out to the antenna. But just remember that we designate that as device under test port. And that is what's going to go out to your antenna or your duplexer or whatever it is that you're testing at that time. And then the other one is the GEN port. It's designated GEN and goes in the GEN port. This is actually an older picture here for our 3500s. We used to call that the SWR port, but it's the same device. It's just got a different name to it. So that's the discrepancy that you see there. So we're going to go ahead and we haven't switched over to DTF here. We're going to do that in a minute. You're going to see this, all of the items in this window are going to change. Our menu structure is going to change a little bit, and then we'll talk about the new items that we see there. So we've got it hooked up, and we did our, we're getting ready to do our calibration here. So we are going to estimate our distance. And the lowest amount of this is 42 feet, and my ground plane with my little antenna on it is I think it's about 27 feet away, 26 feet, something like that. So 42 is as low as you can go, but you can go all the way out to 2,000 feet. So if you've got a very large tower, you've got plenty of capability in here to measure that. I don't think there's any 2,000 foot towers out there, but you could measure a spool of cable if you wanted to. So we set the distance, and then we either set it to feet or meters. So for our friends in Canada and most of the rest of the world, you can set that to meters and then move on from there. You can either set it in VSW or DB, VSWR, excuse me, or DB on the Y units. And I'm showing this demonstration in VSWR. It's a bit of a cleaner sweep, but once you get used to what things look like using these sweeps, you could possibly see a few other anomalies using the DB function as opposed to VSWR, but we're just using VSWR in this demonstration. Okay, so we go down to cable. Now this is one of our new tabs that's come up for us. And we have a library of cables in here. They're all RG type cables. And that's actually what I'm using now. I've got RG, I think it's 142. And so I'm just gonna go in and recall that cable. If you use an LMR cable or some other cable besides RG, you can also store those in here. You just have to find out what your velocity factor is and loss per 100 feet. And you can port that in there so that when you go out to the site, you don't have to go look up what the velocity factor is and the loss per 100 feet. You just recall your cable and you'll be ready to go to make your distance default sweep. So I'm going to pick my cable here, RG142, and I'll recall that. And now we have the velocity factor set at 0.7 and a loss of 8.86 dB per 100 feet. And that will be used in the calculation of our distance default. We're hitting the calibrate button here, and now we're ready to do our distance default. So we've got, at this point, we've taken that 50 ohm load off and we've connected it to our antenna out here. And we've are going to see the spike come up, and that's going to be the end of the cable, or if we're in a troubleshooting mode, we're going to find the anomaly along the way that's possibly causing the issue. If in a troubleshooting mode, what you could do is you could run the VSWR, and if your VSWR is really high, well, you don't want to just run out there and call the climbers and have them go up and change the antenna. You want to make sure what is causing the problem. So if you run your VSWR sweep and you're getting a really high VSWR, 4 or 5, or maybe even 3, which is too much, then you can use this distance default, and it'll tell you where the fault is. If that distance default runs all the way up to the antenna, I'm going to show you what the antenna looks like here in a minute, then the antennas, well, if it runs all the way up to the antenna, then the antenna is bad. But if the distance default only runs part of the way, of course, you kind of have to know the distance, from the base station to the top of the tower. That's something you'd have to know. That's your estimated length. In other words, it's your estimated length. And then you would be able to tell where that fault's at. Is it down at the base station, halfway up the tower, that sort of thing. So this is a real useful tool, especially after you found out that you've got bad VSWR. So let's let it run here a little bit. And we're going to use our marker capability. And the other thing I want to point out here, I'm going to let it move into its zoomed in here. So our sweep rate is extremely fast. This thing updates, probably I haven't clocked it, but it's at least less than a second. It's around that. On some other service monitors, those plots take a long time to calculate. We don't. We're fast. I'm going to put it back into run mode here, and you'll actually be able to see that sweep a little bit now that you're thinking about the sweep rate. So let me get it going again. So you can see it move every once in a while, but we're moving so fast that our sweep rate is just faster than most of the competition out there in this class of service monitor. Now there is another little anomaly out here that I'm going to point out, and it's that one right there. And I actually put this in there, and just to show you that you can see these anomalies on the way. And this is a very small one. It's not causing a lot of consequence to our VSWR, because it actually is in my transmission line when I did my VSWR measurement, and I still got a good VSWR. I might have got a little closer to 1, but I was still, you know, very close to 1 on the VSWR. So this little anomaly here isn't really causing anything, but the point is that you can see these little variances in the transmission line. And so we'll let it run here. I'm moving the marker on top of it here is what I've done. And it's telling us that there is something out there at about 7 feet. And in the next sequence you're going to see here, I'm actually going to go out here and remove that coupler, and you're going to see this signal go up through the roof, because all of that signal is getting reflected back into our receiver at that point. And then I'm also going to show you another little anomaly that we have out here. There's this right here, is actually the antenna. And let's go through this process first. I'm gonna pull that coupler off, and you'll see this come up. And so there it is. Now I pulled the coupler off, and I think I've caught it in about midstream here, because this thing's going to go clear off the top of the screen here. And there it is. So it's clear off the top of the screen. We've lost everything else out here because the cable's not there anymore. I've got it opened up here at 6 feet. I took that coupler off. Just wanted to show you some of that capability there. And the other thing, did you see how fast that was? I mean, it was instantaneous. As soon as I pulled that coupler off, we saw that that signal increase at 7 feet instantly. That's how fast our sweep rate is on our distance default. And we're going to let it run a little bit longer here. Now, what I'm doing here is I'm moving the marker over to the right side of the signal onto that next peak there, the very small peak. But that's actually the antenna. And I'm going to prove that here by pulling the antenna off. So I'm going to scramble up the tower here, and I'm going to take that antenna off there. And now we see that the antenna has disappeared, and the end of that cable has gone through the roof. So what's going on here is, you know, we're doing this distance default, and we're sweeping the signal through our power divider down here. And we had a lower signal earlier because we had the antenna on here. So that signal was getting dissipated out that antenna. So the distance default was smaller. It was the end of the cable, but it wasn't as high as it is now because we were dissipating some of that signal out the antenna. Now the antenna's gone, and our signal looks like it did at 7 feet. And again, I didn't cut this at all. This is how fast that moved. Maybe I ought to watch that again. I'll pull that back just a little bit. So there it is. And when that antenna comes off, and like I said, this is not a video edit here. This is real time. The antenna comes off, and there it is. That's how fast we sweep. So I'll have my tower climber put my antenna back on, and now we've back to our original configuration here. And so that's a little bit about going through retuning a duplexer, full retune of a duplexer, and doing a VSWR measurement on an antenna, and doing a distance default using the tracking generator in the 8800. And by the way, one of our Dave commented the other day that maybe I ought to tell you how to get to the tracking generator. That wasn't part of what we're doing, but you probably might want to know how to do that. I probably should have told you in the beginning if you're trying to follow along. you'll have the video out here pretty soon so you can follow along. But you would hit your gray tab and you would go to the analyzers and go to tracking generator to pick that up. But that's where it's at. So just with these, the tracking generator and these two devices here, you can do all of those measurements. So that's about all we have today. And if you have any questions, you've got questions coming in, we're going to start doing the question and the answer here in just a couple of seconds. But there's all the contact information. If you have any questions or concerns about any items here. And I thank you for joining us. And like it says down at the bottom, please stay online after the presentation is complete for a short 1-minute survey. So let's open the lines up. And Dave and Mike, we got some questions.
Indeed, Bill, we do. Now there are a few questions submitted, so yeah, we'll go ahead and answer those real quick. Before we do the questions, though, Bill, in regards to the instruction on how to get to the tracking generator, I believe there's a handout that Sarah posted in the, I guess in your sidebar there, that you can download that also kind of walks through that Duplexer alignment process, kind of a step-by-step. And I believe that set of instructions does walk you through the process of setting up the tracking generator, changing all the settings and that sort of thing. So please feel free to download that and review it as needed. So yes, there were a few questions as well. And I know Mike has answered quite a few of these already, but just to kind of, for the people who didn't ask the question for their benefit, Mark asked about the 3920, and the 8800 obviously has the VSWR scale as well as a dB scale or return loss scale there, and the 3920 does not have that VSWR, and you can still do a measurement of your return loss, and then of course there's calculators and tables out there on the web that you can download, or apps on your phone you can download that will let you do a conversion if you know what that return loss is, and it's the same process. Like I said, just you'll be measuring in dB instead of VSWR, but you can convert that to VSWR. You can also from that convert that to a percent reflected power that you would have if you were transmitting live or whatever. So it's more than one way to get there. It's just a little bit easier on the 8800 because the scale's already there for it. Yeah,
I didn't mention it, but there is an old school way to do distance default with a spectrum analyzer with a tracking generator. If you, whoever had the 3920 question, if you would like the information on how to do an old school distance default, let us know and we'll give you the information on how to set that up.
Also, Alex asked about the using the inline power meter versus the tracking generator to sweep a system. And there's benefits to both. The power meter, the nice thing about the power meter is that it gives you your forward and reflected power already, as well as that calculated VSWR. It allows you to verify that your transmitter is working and everything as well. The downside to using the power meter versus the tracking generator is that it is at a single frequency. So it gives you a very nice snapshot of the performance at that frequency, and that may be all you need. And if that's good, then you're good to go. If you had a high VSWR there, the power meter doesn't really give you a lot of information about why you have a high VSWR. So so I guess, and I think Mike may have mentioned this in the comment, but and in his reply to that, but the power meter is a good way to kind of initially look at that. And then if you take the system offline, use the tracking generator and the return loss bridge, now you can actually sweep the system over a frequency, and you can see if it's something, if you have a very high VSWR across your entire sweep, then there may be an issue with the cable or a connector or something like that. if you find that maybe the VSWR is really good, 5 megahertz away, then you may find that you may determine based on that it's just a matter of the antenna tuning being wrong, and that's something that I've talked to people who do installations, and one of the nice things about using the tracking generator is that if you have a new install, you can go out there, sweep the antenna, verify it's on frequency without hooking up your transmitter and possibly endangering it. If you had, say, your install team came in and put a VHF antenna up instead of a UHF antenna. So it gives you, I guess, a more complete picture of the health of the system. Let's see
hey Dave,
here.
I'll take one there.
Okay, go ahead. Yeah.
There was a question about when to do the reference calibration when you're using a return loss bridge. So you do connect the return loss bridge before you do the reference, because that will zero out the loss of both your interconnecting cables and the return loss bridge. The return loss bridge will have roughly 12 dB of insertion loss just inherently in the bridge itself. So all of that gets zeroed out when you hit the set reference.
Thanks, Mike. Liam, the recording of the webinar, once it's posted, you'll receive an email with a link to sign in and access the recording. So I think Sarah said, 24 to 48 hours, we should have that up on our website, and you should receive an email at that time. Mark, do we have a distance default return loss PDF handout? I believe we do. Let me check and see if I have that available. We'll send it to you offline though, and then if it may be on the website, I'll have to look and see. But we'll get back to you with that in PDF form. Let's see here. And I guess going back to that the inline power meter versus the the return loss bridge for doing those measurements, that is something that's, I guess, it's nice to have on the 8800SX. If you had your old Bird power meter you carried out with you and all the various slugs, it's I was going to say it's one less piece of equipment that you have to remember to take out with you, but really it's not. It's multiple pieces you don't have to take out with you because it's all built into the 8800. It's going to be on frequency. You just put the frequency in, and it automatically is calibrated to that frequency. There's no slugs to turn around or forget in the shop, and that's something that it's kind of unique to the 8800SX. You don't have that built-in inline power meter and other service monitors. So let's see here. Yeah,
there is a good question here.
They're all good questions.
They are. There's no bad questions. The 3550R has a built-in return loss and VSWR measurement that it can do without the use of an external bridge. It also supports the use of an external bridge. But what's built internally is completely different type of hardware, and it is more susceptible to high power or interference at a site. If you're at a site sweeping an antenna, the return loss bridge is much less susceptible to that. So the bridge is a better choice in a high RF environment. And again, the 3550 does support both methods.
Kyle, there is a I guess it's not so much an FAQ type of thing, but there is a list of, I guess, guides or PDFs walking through various topics on the 8800SX webpage. So if you go to viavisolutions.com and search there, there's a search tool up in the upper right corner. Do a search there for the 8800SX. And below the pictures of the unit, there's a resources and literature section right below that. And towards the bottom of that page then is a list of various PDFs you can download that go over various, I guess, topics. There's one there, for example, that has that covers basic tests. So basic transceiver tests, receiver transmitter, distance default. I think there's a short section in there about distance default and return loss measurements. So like I said, it's at least a very good starting point. And the other thing I guess I'll point out real quick here, for anybody really, if you have a question about a specific thing you're trying to do and you can't find the information online, I think Bill put our contact information in there in this presentation, or the last slide there had the email address. Please feel free to email us and reach out and ask that question, because that's why we're here, is to keep you doing what you do. So thanks, Bill, for putting that back up.
You bet.
Mauricio, no, the 3920 does not have a distance default option. That was the there is a way to do that distance default measurement with just the spectrum analyzer in the 3920, but that's is a separate thing. It's not a dedicated distance default measurement like the 8800 has. We've reached I know we've gone past the 1 o'clock mark. Why don't we, I know there's a few more questions, but why don't we go ahead and we'll wrap up now. Like I said, since we've reached that 1 hour point, and we'll answer any of the remaining questions offline via email, or I guess if necessary, give you a call. But I want to thank everybody for joining us. Sarah, did you have anything you wanted to say in closing?
No, that's it.
Okay. All right. Well, thanks again, everybody, for joining us, and hopefully you all learned something. Again, if you have questions or comments, now, later, whenever, you're at your site, you're trying to do a measurement, you can't remember how, please feel free to reach out, give us a call, or drop us an email, and we'll be happy to help you. So thanks, everybody, for joining us, and have a good day.
Thanks a lot, folks.